The next item in our review of the mathematical underpinnings for this course are sequences and tuples. A sequence is a list of items in a specific order and in which duplicates are allowed. These two things separate a sequence from a set. We normally indicate a sequence by enclosing the items in parentheses. For instance, I might indicate a particular division operation as a sequence consisting of the numerator as the first item and the denominator as the second. Clearly, if I were to swap these two, I would have a different division operation, and therefore order is important. The size of a sequence, often called its length, is indicated by the same use of the absolute value operator and may be either finite or infinite, just like a set. In this course, almost all of the sequences that we're going to work with are going to be finite in length. As indicated, the order of a sequence matters. That's because the meaning of an item is often determined by its position in the list. The meaning of a denominator is different than the meaning of the numerator. We only have one particular operation that we're going to use to operate on most sequences, and that's the cross product. There are also particular kinds of sequences, such as strings, that will have other operations that we can perform on them, but we'll talk about those when we need to. Defining a sequence is quite a bit more involved than defining a set. When we define a set, because order doesn't matter, we just have to define the rules that establish what is and what is not in the set. In a sequence, each position in the sequence may be drawn from a set, and different positions often use different sets. Even if the two positions are drawn from the same set, the rules that apply may be different. For instance, I might have three positions in a sequence that are all drawn from the set of natural numbers, but the first item might have to be an even number, the second item might have to be a multiple of 3, and the third item might have to be a prime number at least as large as the value that's in the second position. We can also have sequences where a particular member is a set, and vice versa. Sets often have sequences as members. A particular sequence that is very useful sometimes is the empty sequence. Similarly to how the empty set can be indicated by a pair of curly braces with nothing in between, we can indicate an empty set with a pair of parentheses with nothing in between. Furthermore, just like the null character is a special character used to indicate the empty set, the lowercase Greek letter epsilon is frequently used to indicate an empty sequence. We'll hear the word tuple a lot. And a tuple is nothing more than a finite length sequence. A k-tuple is nothing more than a sequence having a length of k. Two tuples are so common that we often just use the term ordered pair to indicate them. Now you will hear both tuple and tuple used in practice, and there's no distinction between them. It's just different preferences for how to pronounce the word. I tend to prefer tuple, not only because I think that that is how the normal rules of English would pronounce the word, but because I think of its origins as coming from the word multiple. Now for that cross product. The cross product produces a set of sequences given a sequence of sets. What do I mean by that, and how does it work? Let's say that we've got three sets, F, G, and H, as shown here. The cross product of f crossed with g crossed with h, sometimes written as the function cross acting on the sequence fgh, is defined as the set containing all possible sequences in which the first element of the sequence is drawn from f, the second element is drawn from g, and the third element from h. The size of the cross product of a sequence of sets is simply the product of the sizes of the individual sets. Frequently, we will cross product a set with itself, maybe multiple times, and a shorthand for this is written as the set raised to the exponent k, where k is simply the number of times a is crossed with itself.